Okay. Yeah, so far we have discussed scale product. Yep, so look at the scale. Yep, so we operate two vectors. We take the product of two vectors, and the resultant one would be a scale real number, right? But this time, this is another operation. So let's say this is V is my set of all numbers. So cross product, right? When you operate any two vectors, so you get another vector, right? So it is denoted by A cross A cross B. Yeah. All right. Vector product. Yeah. So why we call it vector product? The resultant one is a vector. Why do we call scale product the resultant one? Yeah. We do take the dot product. The resultant one would be a number, right? This is a number because this is a magnitude of A magnitude. Yeah. So yeah. I have files. Right. Yeah. So magnitude of A is quantity. Yeah, positive quantity or non-negative quantity. Magnitude of B is another non-negative quantity. And cosine could be positive or negative. Yeah. Yeah, between positive one and negative one. Yeah, so yeah. But the vector product gives you when you operate two vectors under this operation. Yeah, so this is a vector, this is a vector. Yeah, so this one we okay, so this is the definition. Yeah, so when you operate two vectors in this way, so we denote it as a cross. Yeah, this is some people call cross product. Some people call this vector product. Right, this is the definition. Right. So magnitude of A times magnitude of B sine of theta. A, vector B. This is the angle theta. This theta varies from where to where? From 0 to, from 0 to theta varies, from, this side or that side. Okay, negative pi to positive pi. Yeah, so theta in between negative pi and positive pi, or you can say, if you are measuring only positive, positive angles. No, I think this is better. Yeah, theta in between negative pi and positive pi, right? Magnitude of A, magnitude of B is cosine sine of theta times n. N is the unit vector which is perpendicular to the plane of AB. Unit vector, right? So how do you find the direction of this unit vector? Yep. So it is a unit vector in the direction perpendicular to both A and B. Yep. Yep. So both A and B. So how do you find the how do you find the direction of it? That means direction of A cross B, right? So you have to use your right hand side to get the direction of A cross B, or is a unique vector, right? So take your right hand side. Yep. So get your right hand side, right? Okay. So here, how do you find the direction of A cross B? Because this is a vector, cross product is a vector. That's why we had to. So this has not only the magnitude as well as the direction. So the direction of A cross B is direction of this unit vector, right? So how do you find the direction of this unit vector? Definitely you have to use your right hand side. Yeah, so right hand side. Take your right hand side, right hand, right? Okay, and point your thumb. Yeah, so point your thumb along this vector. Yeah, so take your right hand and point your thumb along. Yeah, thumb along this vector and point your index finger. Yeah, along vector B and the middle finger. Yeah, yeah, and yeah. So and try to make perpendicular. Try to make this middle finger perpendicular to both A and B, and the direction. Yeah, so the middle finger gives you the direction of A cross B. Yeah, so how do you draw this? So this is your middle finger. Yeah, so A B and middle finger. Yeah, A B. Vector product gives us the three-dimensional vector product. Does it? No, so this is the general definition for any dimension, right? For any dimension, this is the general definition. So it could be n dimensions, right? And this is the general definition. Okay, not only for three dimensions, but for n dimensions. This is the general definition. This one also, this is the general definition for scalar product. Okay. So later, yeah, you can use right hand Sanjay. Yeah, you can use right hand screw rule. Yeah, yeah, that is much easy. Yep. Or this one. All you need to do is find the direction of A cross B. Okay. Right. Okay, let's as we discuss in scalar product, we discuss properties of scalar product. Let's see whether the vector product or cross product satisfies commutative property. Let's see. A cross B is A with B cross A. Can we change this orientation? Can we change these positions of A and B? I think no, right? You cannot change. Yeah, if you change A, B, you get different. If this is, yeah, if this is, let's say, if you multiply So what is this? What is the direction of this one? You get what is the direction of this? You get opposite direction, right? Other way around. Right. B cross A. Use your right hand side. So this time you have to point your thumb along vector B, vector B, and point your index number along vector A, then middle finger gives you the direction. Then the direction of this one is reversed, is opposite of direction of AB. So that's why the commutative property does not hold. Okay, it is not commutative. Okay? The order matters. When it comes to the cross product, order matters. Dot product order doesn't matter. Okay, order doesn't matter. But cross product order matters. This is not equal to B cross A. But it is equal to negative. Negative. Equal to negative. Yeah, Sanjay, give me a second. Yeah, I will answer to that. Yeah. Yep. So, and yeah. So, but you can use yeah. So, for any dimension, yeah. So you can find the magnitude, and you can find the magnitude of A and B. And if it is a dimension, yeah, you can find there's an angle anyway, theta, and you have this unique vector. This works for any dimension, I think, not only for three dimensions, but also for any dimension. So, but there's another definition for cross product. Yeah, this definition. Yeah, so if it is a three-dimensional one, yeah, so yeah, this one, yeah. So, yeah, so A cross B is equal to the determinant of this, yeah, determinant of this, yeah, this matrix. Yeah, this is only for three dimension, but this definition, okay, yeah, this definition, yeah, is true for any dimensions. Any dimensions, yeah. Okay, all right, Sanji, yeah. Can write the dimension of fan. How we can write dimension of file? Though earlier in the problem, consider a vector space in in dimension. So they mentioned in the problem at the beginning, you have so consider this vector space. So this is vector addition, and this is yeah, this is scalar multiplication. Yeah, so consider this vector space, and you can define a product between you can define any product. Generally, you can define inner product between any two vectors. Yeah, for any dimension, this can be defined. One of particular one is dot product. Dot product is A1 times B1 plus A2 B2 plus dot 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 A B. Dot product gross product is magnitude is square root of sum of all things Sine theta is the angle in n-dimensional space. So here vector in n-dimension, and there's an angle you can measure in any dimension, right? Angle between any two vectors. And is the unit vector which is perpendicular to the plane of A and B. Yeah. So this satisfies in any dimension. Okay. All right. Let me do this. Then I will answer to your questions. Otherwise, we have limited time, right? All right. So yeah. So yeah, that cross product satisfies speed law. Not associative. Yep. So it is not associative. Yeah, it is. Yeah, this is not true. Yeah, so you will see that this one is not true when we talk about a vector triple product. When we talk about vector triple product, you will understand that this is the result. Yeah, this result is different from this. Okay, non-associative. Okay. Yeah, so if you have a scalar, yeah, you can move this scalar into A and B like this. Yeah, that's better. Yeah, so scalar does better. This is important, right? When if you have non-zero vectors A and B are non-zero vectors, A, B, let's the cross product gives you zero. Zero is zero vector. Zero vector. Because output is a vector, right? Output of a cross product is a vector. Then what happened? Yeah, what happened? This is equal to magnitude of A, magnitude of B, and sine of angle between A and B, and uh, yeah, unit vector. So we know that A and B are not zero. Yeah, so you can divide A and B by both sides because not zero. Magnitude of A, magnitude of B, yeah, magnitude of A, magnitude of B. Now cross this off, then this becomes again zero. Yeah, zero is equal to sine of theta and n. So n is a unit vector, right? The magnitude of this one is 1, right? So therefore this term should be equal to 0. 0. Yep, so this scalar should be equal to 0. 0 should be equal to sine of theta. That means we know that range of the theta, yeah, theta varies between negative pi and positive pi. The theta would be 0 because 0 is equal to sine theta. Theta could be 0 or pi. That means A and B are parallel. On this side to other side. Yeah, parallel. Yeah, if your yeah if the vectors are parallel, if A and B are parallel, the angle is 0 or pi, then the cross product gives you 0. If the cross product is 0, then and if these are not zero vectors, then A and B are parallel. Got it? Asking, that is what guy is asking if whenever A, B, and C are, yep, so when you take the cross product of these three vectors, if this is equal to 0, B is what? Yep, so Yeah, so we can say according to cross product, yeah, A is parallel to B cross C. Yeah, that means here you have B, here you have C. Yep, so A cross B is direction of A cross B is here, and this is A. Yeah, when you take the cross product between A and B cross C, that gives you 0. Then you can say this implies that A and A cross B, yeah, A cross B 0. That means you can say that BA is perpendicular to both C and B. Yeah, we can say that vector A is perpendicular to both C and vector B. Got it? Yeah. So now we can take the cross product of these unit vectors, famous unit vectors. These are unit vectors along OX. I, J, K are unit vectors along OX, OY, OZ respectively. Yep, so they are perpendicular each other, right? So if they are perpendicular, yeah, I cross itself. Yeah, what is this? What is the resultant? Yeah? When I take the cross product with itself, yeah, when I take the cross product of zero vector, yeah, because they are parallel. Zero vector, yep. So J cross J also zero vector. Don't put only zero vector because output is a vector, right? Output of a cross product is a vector, right? K and K cross K also zero vector because they are parallel, right? So if you take the dot product with one of these unit vector with a different one, let's say J. What is the resultant one? Let's find. Yep. So A cross J. Aha. So let's use the definition. Definition of cross product. Magnitude of I, magnitude of J, sine. What is the angle between these two vectors? Sine of. What is the angle between I and J? This angle
Pi by 2.
pi by 2. Yeah, that's right. Pi over 2. Pi by 2, 90 sine of. Yep. And what is the unit vector which is perpendicular to these two vectors? Yep.
K.
K, yeah. That's right. Yeah, this is 1 and this two both are 1. Yeah, so therefore, yeah, that's why you get K. I cross with J is K. Yeah, J cross with K is I. J cross, yeah. So this is I, J, K. Yeah. I cross with J is K. K. J cross with K is I. J. K cross with I is J. This is circular permutation. Circular permutation. Yeah. So there's a circular permutation of vector product here. Right. Yeah. All right. So when it comes to three-dimensional vectors, Yeah, so let's consider your vector space is three dimensions. So earlier, any dimension, general dimension and dimension. Now we talk about a particular case, three dimensions. Now A, B are three-dimensional vectors, right? By the direction. Okay, let's I will take that later. Yep. So yep, A cross B. So A, B are three dimensions. A has three components. This is the X component, Y and Z component. Cross with vector B. This is vector B. X component, Y. So so this is you can yeah. So we have this result. I cross I is equal to 0. Yeah, J cross J 0. K cross K is also 0. And we have this, yeah, this result. Yeah, you see this result. Yep, so we can find this cross product. So how do you find? Yeah, so yeah, here, yeah, let's write this one in terms of I, J, K. Yep, so AX is the X complex I unit vector plus AYJ one and two cross with this. So yeah, so with this, we know that cross product satisfies distributive law, right? This holds. Yep, so this one is equal to A cross C plus B cross C. A cross C plus B cross C. Yep, so because it satisfies distributive law, yeah, you can distribute this. So you can distribute this, yeah, this term cross with this one, and this one. When you take the cross product with this term with these two, you get no. So cross product of this one with this is 0 because I cross I is 0. So you have other two terms. Yep. So yeah, complicated. Yep. So I cross I is 0. And also J cross J is 0 and K cross K is 0. So you don't get those terms, but you get other terms. Let's write them down. Yep, so you get, yeah, this one cross this. Yeah, what is the value of K cross I? So how do you find I, J, K? Yep, so we have the circular symmetry. Yep, circular symmetry. Yeah, K cross I. K cross I is J. Okay, J. Yeah, so therefore, yeah, this one A Z like that. A Z B X J. J. Yeah, let's multiply, take the cross product of these two. I, yeah, J cross I. Yeah, J cross I. This is J cross I. I cross J is K. I cross J is K. J cross I is negative K. Yeah, negative, negative K. Yeah, yeah. A Y, like that. A Y B X K. Like that, you can write that. So here like this here. So jth one a z, yeah, positive a z bx positive. So like that you can expand this because cross product satisfies distributive law, right? Expand this and you can come up with this equation, this one. This is with the determinant of this matrix. So if you have three-dimensional vectors, A and B are three-dimensional vectors, so easy to compute the cross product. Yeah, so just yeah, it is equal to the determinant of this matrix. Yeah, let's compute. Yeah, for instance, yeah, if you have three-dimensional test, let's say A is equal to 1, 1, 1. Yeah, this is a three-dimensional vector. This is the vector space. B is another element of vector. 1, 0, 1. Yeah, let's compute because we are learning. We are learning cross product first time. Yeah, let's compute a cross product. How do you compute? So because there are three dimensions, so that gives you the determinant of this matrix. J K, write the unit vectors, and then vector A, put the coefficients. Coefficient of x is 1, coefficient of y is equal to 1. What is the coefficient of z? 1. Yeah. And the coefficients of b. Yep. So 1, 0. Yeah. So now, yeah, simplify this determinant. Yeah. So how do you simplify this determinant? Yeah. So yeah, take this one. Side is positive. Yeah. Yeah. You have to. Yeah. So how do you simplify this determinant? Yeah. Yeah. First element is I, and the sign is positive, right? And avoid the first row and the first column, and you will get this matrix and take the determinant of that matrix. 1 times 1 minus 0, this one. Okay? Yeah. Now the second one, this time the sign is negative, right? Sign is negative. And how do you find the coefficient? So remove the first row and the middle column, and you have this matrix 2 by 2 matrix. Yeah, take the determinant of that matrix 0. Okay, done with that. Yeah, now, yeah, so this one, the sign is positive, positive K. We find the coefficient. Yeah, remove the first row and the last column. Yeah, then you will get this matrix. The determinant of this matrix is 1 times 0 minus 1 times 1 is negative. Right. Yeah, so the cross product of A and B is I, yeah, 0 j. We don't need to write 0 times minus k. Okay, like that. Yeah, if the vectors are three-dimensional, three-dimensional vectors, yeah, you can use this, yeah, this definition. If in general dimension, you have to use this definition. Okay. Okay, that's the difference between those two definitions. All right. So let's move on. This is one of application, right? Yep. So you can find the area. Yeah. So can you explain that again? How minus yeah. Yeah. I hope these two is clear. So yeah, the sign alternating right here. This portion is positive, negative, and positive again. Is that clear, right? K, yeah. So avoiding. I'm going to avoid this column and the first row. Then I left with these elements, these four elements. Then I have to take the determinant of these four elements. What is the determinant? 1 times 0 minus 1 times 1. Okay, 1 times 0 is 0, minus 1 times 1 is negative 1. That's why you get negative 1. Got it? Is that clear? The geometric representation of vector product. Really, so yeah, so okay, yep. So what is the definition of vector product for any dimensional vectors? That's the definition. Yep. So magnitude of A, magnitude of B, sine of angle of A and B, angle between A and B, and the unit vector. This unit vector is perpendicular to the plane of A and B. Or this unit vector is perpendicular to these two vectors A and B. Right. So, okay. Right, let's draw. Let's draw it up. So you have two vectors. OA is this. OA represents vector A. OB, yeah, this is OB represents vector B. Yeah, you can complete this parallelogram. As I said before, vectors do not have a specific position in the space. Yeah, so direction and the magnitude are the same. Yeah, this will be P, and this one goes A. So this is the angle between two vectors theta. All right. So if I drop a perpendicular to the OA line, dropping a perpendicular. Yep. So this is the projection of A on OA. Yeah. What is the projection? This much. So that projection would be B, magnitude of B. No, not projection. Yeah, so, not projection. Yeah, so let's because here you have side term. Yeah, so I have to consider this the height of this parallelogram. Yep, so what is that? Yeah, so sine b the magnitude of to be sine theta. So what is the area of this parallelogram? OA, I will say this is C. So what is the area of OACB parallelogram? How do you express this in terms of cross product of A and B? How do you express this? Yeah. What is the area of? So express this the area of parallelogram in terms of A and B vectors, or this one, or cross product. Yeah, it is magnitude. Take the magnitude. Magnitude. So this is magnitude. Magnitude of n is 1, right? So it is equal to the magnitude, the area of OACB parallelogram is equal to the magnitude of A cross B. In other words, so what is the area of OAB triangle? The area of OAB triangle, yes. What is the area of OAB triangle in terms of cross product? Yeah, one half of this. Yeah, one half. Yep, so yeah, this is one of applications. Yep, so this gives you the parallel area of parallel. Yep, so yeah, find the area of parallelogram defined by these points, these coordinates. So origin is 0. This is A, is a position vector 1, 3, 4. Another vector B, 2, sorry, 2, 1, 3. Then you can, yep, so yeah, you don't need to, yep, so area of parallel defined by this, yeah, yep, so this is the completion of parallelogram. Yep, so the area, yep, so the area of this one is A cross B. Yep, so magnitude of A cross B, first find the A cross B. How do you find the A cross B? Yeah, let's find it together. Because we are doing this first time. That is A vector A is 1, 2, 3, 1, 3, 4. 3, 4, three-dimensional vector, three-dimensional vector. B is 2, 1, 2, 1, 3. This is A. So A is B. Yeah, what is the area? The area would be A cross magnitude of A cross B. First find A cross B. How do you find? Because these are three-dimensional vectors, we can use this definition. Okay. I, J, K. Yeah, so A is 1, 3, 4. B is 2, 1, 3. Yeah, the first one is positive I, and the coefficient would be without considering the first row and the first column. Then take the determinant of this 9 minus 4 is 5 minus 3. Yep, so removing the first, this second column and is ij case. Then we left with 1, 2, 3, 4. Let's find the determinant of that matrix. 1 times 3 is 3 minus 8 is negative 5. Negative 5 positive, negative 5. Yeah, yeah, positive. J, K. Yeah, without this first row and first column, the third column, we left with these four numbers. And let's find the determinant. 1 minus 6 is minus 5. Yeah, magnitude of, yeah, cross product of A and B is 5 is common. Scalar 5 is common. Yeah, J minus K. The magnitude of this matrix vector. What is the magnitude will be, yep, so square root sum of square. So square root of sum of square is this. Then the parallelogram, area of parallelogram known 1/2. This yeah, 1/2 is the triangle of OAB, area of OAB. Yeah, this is yeah, so this makes sense. Yeah. Yes. Yeah. So we have only 8 minutes left. I think we done with cross product. Yep. So here we have another example. Yep. So P lambda C. So they're asking us to find A cross C. Let's take the cross product. Yeah. And what is this? Distribution law is cross product satisfies distribution law. Distributive law. C lambda C cross C, the C cross C is 0. Cross C, yeah, 0 vector. Therefore, this is true. Okay. Yeah, so this is one of application talk if you want to find the talk. Yeah, so talk around the origin, which is the F cross F, yeah, position vector cross. You have to use the cross product, the position and the force acting on. Yeah, so all right. So let's go to the next one. We have only 5 minutes up, so we don't have time to explain scalar triple product. I will discuss this next week. Lateral jump, so I have to cover. Yeah. So then we will talk about the line equation, line representation in vector form. Yeah, next week. Okay. So we have an idea about the difference between scalars and vectors. Yep. So vector has two quantities. What are those? They have magnitude as well as a direction. Yeah, but scalar has one property, only magnitude. Yeah, so you can stretch, you can, when you add two vectors, you will get another vector because, vector addition is, satisfies closure property. That means when you operate two elements, you get, so if you have a set of vectors in V, right? So V is the set of vectors. If you operate addition vector, add these two, you get another vector. So then we say, yep, so vector addition is closed. Right. Yep, so it satisfies vector addition, satisfies closure property, and the way you add does not matter. You can change the orientation, right? You can change the way it appears. Yep, so you can change the orientation you get. Yep, so both are same. This one distributed low satisfied. Yeah, so you can stretch and string the vector, or uh, you can you can reverse the vector if you multiply a negative quantity. Uh, this is a vector space. You see second year. Yep. So my position vector is a vector. Yep. So we discuss unit vectors. And yeah. So then we discuss vector addition, vector multiplication. Here we discuss two types of multiplication. One is scalar multiplication, and another one is vector multiplication. So you can define different multiplications, right? So in second year you will define any type of multiplication on the inner product vector, inner product. Yeah, so you can define any so here we discuss only two types of multiplication: scalar multiplication and vector multiplication. Yeah, scalar multiplication, the output of the scalar multiplication is a scalar. Okay. Okay, and if you have perpendicular non-zero vectors, so when you take the dot product, you get zero all the time. And yeah, so these are so you have to know, you have to remember these properties in the exam, right? And if you want to find the angle between two vectors, here, so this is the way, Sanjay, this is the way you find angle between, if you have n-dimensional vectors A, B, A1, AN, n-dimensional, another vector B1 up to, there are n number of components, Bn. So cos theta is sum of AI, Bi divided by magnitude of, AI squared. So Bi squared. Okay. So this is n-dimensional. So this is how you find the angle between two vectors in the n-dimensional. Is that clear, Sanjay? Yep. So like that. So these are general definitions. This satisfies in any dimensions, right? Yeah. This is another general definition. So for any dimension. Yeah, so you can use this, but for three-dimension, you can use this definition. Okay. Yeah. So we talked about the vector product club. So the resultant one of this one is a vector. Yes. We discussed that. So make sure that that does not satisfy whole, does not hold commutative property. That's not distributed property. Yep. Yep. So these are important in the exam. Right. These are important in the exam. Right. Yes. Yeah. Geometry representation. That's all. Yep. So that's all. Yep. So this is. So do you have any question? Global vector is the. Yeah, I will tell you a little bit about it next week. Okay. Okay. Any questions? Any